negative side effects. Let's see. What about blood doping? It's the primary mechanism of how blood doping or EPO injections, how they enhance performance.
Recovery.
Recovery's one, but let's say if I was doing an exercise bout, would it help me run faster or run longer? Yes, because of increased oxygen delivery to the working muscles. When I blood dope, I essentially am adding additional red blood cells to my body so I can carry more oxygen to working muscles. So that'll increase VO2 max and increase in performance. What type of events would see an improvement in performance with blood doping? Primarily endurance type events. I'd say events that last about 5 minutes and longer are going to be the ones that are going to see big improvements with blood doping. What are some of the consequences of blood doping or EPO use? Makes your blood very thick, which can lead to heart attacks and strokes are the two biggest ones. Also, you can have transfusion reactions or any sort of blood-borne disease transmission if you're using. If you're doing autologous blood doping, whose blood are you using? Using your own. And if you do homologous blood doping, it's somebody else's. Okay. That's good for now for ergogenic aids. I don't want to go too long. Any questions about ergogenic aids? Remember, big things are how do you use it? What events does it affect? Is it competition or is it in training? What are the consequences? How much can it enhance performance? If you can answer those questions, it'll be fun. Okay, body composition and obesity. With underwater weighing, what are we actually determining when we do underwater weighing? We're measuring body volume, which can then be used to figure out body density. Okay, do we actually measure percent fat? No, we don't measure percent fat. What do we do to get percent fat once we know volume and density of your body? We put it into a regression equation, and we estimate percent fat. Okay, when physiologists talk about body composition, how many compartments do physiologists divide the body up into? Is it 2 or 3 or 4? It's 2. And what are the 2 compartments? Fat mass and fat-free mass. Okay, what are some of the assumptions, for example, when we do underwater weighing? We have to make some assumptions.
That the density of everybody's bones and muscle.
Yeah, that the density of all the components of the fat-free mass are the same. Okay, we have to assume they're the same. Basically 1.1 grams per liter. Does that hold true for everybody? Is everybody's bone density the same? No, it's not. Okay, so that's one issue or one assumption. What else? What are some potential sources of error when you do underwater weighing? Not vital capacity, but residual volume. Okay, you have to measure and account for residual volume. Okay, that's a big source of error. Okay, and there are some others. Make sure you know what the assumptions and limitations are for the measure. Compared to, let's say, well, let's do this. When you do underwater weighing, what are the things you actually have to measure? Calculate somebody's percent fat through underwater weighing. What do you have to measure? You've got to measure their mass on dry land, right? You have to measure their mass underwater. Is that it? You don't even know their height. What's that?
The weight of the water that displaced.
The weight of the water displaced we know is going to be proportional to their mass underwater. So once we know their mass underwater, then we can then essentially calculate the weight of the water displaced. So we have to measure mass on dry land, their mass underwater. A couple other things we have to measure. You said it. We have to measure residual volume, or we have to estimate residual volume. And there's one other thing you got to measure.
Temperature of the water.
The temperature of the water. Okay. Those are the 4 things you have to measure. Okay, what do you measure when you do skin folds? What are you actually measuring? You're measuring subcutaneous fat thickness. Okay, and we take it from several sites. This is what you'll do next week or when you come back in lab. Right? And then once you have those sites, what do you do to get percent fat? You have all the skin fold thicknesses. What do you do to get percent fat? You put it into a regression equation. What's the biggest source of error when doing skin folds? Technique of the tester. Okay, the person taking the measurements. That's the biggest source of error. What's another source of error when doing skin folds? What about their regression equations? They have to be specific for the population of the person you're testing. Okay, so we have regression equations for women, for men, for old, for young, for different racial groups, for different athletic populations, and the regression equations are different. You have to make sure and use the best one that fits the population you're testing. Okay, why would it be an advantage? Which one's more accurate, underwater weighing or skin folds? Excuse me, underwater weighing is, but why would you ever want to use skin folds? What would be an advantage? It's easier, it's cheaper, it's faster. If you were doing a large population of subjects, it would be much easier to do skin folds. Okay, or do BIA, bioelectrical impedance analysis. When we do BIA, again, we'll do that when you come back from break. What do we actually measure with BIA? We measure the resistance of an electrical current passing through your body. Okay. The resistance of an electrical current passing through your body. Is fat a good conductor of electricity or a poor conductor of electricity? It's a poor conductor of electricity. Okay. So what would be an advantage again of using BIA versus underwater weighing? It's very quick, easy, simple, and fast to do. Okay, questions about that? With obesity, what's the single greatest correlating factor to obesity? It's what? Physical activity when? Physical activity before puberty seems to be the largest correlating factor to obesity. And why is that such a big deal, physical activity before puberty? What happens at puberty?
Like the number of fat cells that you have.
Right, that's called the set point theory. And the set point theory believes that the number of fat cells that you have in your body will become set at puberty. Okay, and why is that a big deal? Okay, because basically your ability to gain and lose weight and fat mass is at least in part determined by the number of fat cells you have in your body. Okay, so when an adult gains weight or loses weight, what changes? Fat cell size or fat cell number? Fat cell size changes. Okay, so that's why physical activity is important before the end of puberty, because you can actually change the number of fat cells before theoretically the number gets set. Okay. With obesity, we talked about that. We also talked about why are starvation diets. What's one problem with like a starvation diet or a severe calorie-restricted diet? What's one of the consequences of that? Yeah, your basal metabolic rate goes down. Okay, so that's why it's important not only to modify caloric intake, but also to modify exercise as well. Okay, let's see. We talked about a few different studies that also talked about, is it as simple as calories in, calories out for losing weight? Is it that simple? It's not, because remember the study that we looked at that had the rats that ate the different diet? There was rats that ate a normal, healthy, balanced diet, rats that ate the same number of calories that had high fat and sugar. And then we had rats that ate lower calories but had, say, high fat or high sugar. Which rats gained the least amount of weight after a certain period of time? The rats that ate the normal, healthy, balanced diet. The ones that even ate fewer calories but that were high in fat and sugar gained more weight and had higher percent fat afterwards. Remember that?